Spectrum, a free service of the cable communications industry and your local cable company.
He was called Mr. Tornado. His life, a series of unexpected twists. His legacy written on Earth's most violent winds. He would often recall as a small boy his father telling him that nothing in this world remains unchanged. In the end, he would leave this world having changed the way we look at storms forever.
Well, prior to World War II and in the earlier part of the century, very little was done on tornadoes. In fact, the Weather Bureau, United States Weather Bureau, did not issue tornado warnings or tornado watches because the Weather Bureau was concerned that such warnings might panic the populace.
Public awareness of tornadoes at that time was not as great. There were things that happened out in Tornado Alley, out in Oklahoma, in Kansas. Dorothy and the Wizard of Oz certainly made people aware of them, but they weren't the kind of things that could strike any state within the United States. They weren't the kind of things that people thought of as potentially striking at any time of year.
Near the close of World War II, there were a couple of airplane accidents, commercial airplane accidents, that caught the attention of Congress. One of them, the senior senator from Minnesota, was killed in an airplane accident. Another airplane flying at an assigned altitude of 3,000 feet in thunderstorm conditions had some trouble and ended up piling into the ground. So Congress passed a joint resolution that authorized and required the chief of the Weather Bureau to investigate the internal structure of thunderstorms, particularly with regard to turbulence and downdrafts.
The eldest child of Yoshi and Tomojiro, Tetsuya Fujita was born on October 23, 1920, on Japan's southernmost island of Kyushu. He possessed an ability to see and understand the world around him as few could, and his powers of observation won him many honors in school. By 1943, war had changed life in Japan forever. Tetsuya had become an assistant professor in the physics department at Meiji College. On August 15, 1945, World War II came to an abrupt end after the first atomic bombs were dropped on Hiroshima and Nagasaki. Fujita recalled hearing air raid sirens on the day of the bombing, and later learned that the initial target of the second bomb had been an arsenal 2.5 miles from his school. Several weeks later, Fujita and a group of students were sent to Hiroshima and Nagasaki to survey the damage caused by the blasts. The devastation was horrific, but as he looked closer, Fujita began to see a pattern of damage caused by the shockwave that would ultimately help shape his understanding of violent storms. In 1949, after speaking at a local weather service meeting, fate stepped in the path of Tetsuya Fujita once again. At the conclusion of the talk, Fujita was told that a copy of a paper written by an American professor entitled Non-Frontal Thunderstorms was found in a waste paper basket at a U.S. Air Force weather facility on the island. The author was Dr. Horace Byers of the University of Chicago. Armed now with a contact in America, Fujita sent Byers copies of his own work, which had received little attention in his homeland. Byers was impressed. A journey that would lead to America had begun.
Horace Byers became aware of a young physicist in Japan that was doing some very credible analysis of meteorological events. That chap's name was Fujita, Tetsuya Fujita, and Byers asked if he would like to come to the United States.
In 1953, the airfare from Japan to Chicago was $650, roughly the equivalent of 13 months of Fujita's salary. Nonetheless, the decision was made to borrow the money, and on August 8th, Tetsuya Fujita left Tokyo, bound for California. He would later describe the trip as his first fly now, pay later plan.
Byers obviously recognized that Fujita was doing a good job in the analysis of data. But the thing that it may not have been his studies of clouds that was as interesting as his studies of the radiation patterns on the bamboo flower pots in the cemeteries under and nearby the locations where the atomic bombs were set off.
Apparently some of the burn marks and the shadows of certain types of poles was able to actually calculate exactly how high the bomb exploded above the ground. And that actually wasn't known. People weren't sure whether it exploded upon impact or whether it detonated above the ground. And he, even though he didn't know, was able to reason out that in fact, based on all the damage, that in fact it had to have exploded above the ground. And he figured it out to the meter exactly how far above the ground it was. And to me, that was remarkable.
For that analysis clearly indicated a superior ability to see details and put them together into a coherent pattern. And Ted was very good at that.
With a 2-year research assistant position awaiting him in Chicago, Tetsuya set out by train from California. Not allowed to bring more than $22 into the country, Fujita purchased a 3-day supply of fig bars and Coca-Cola for the journey east. By the time he arrived in Chicago, Fujita had sworn off fig bars forever. Coca-Cola, however, remained his favorite drink. Tetsuya had arrived in America.
Now, from the Weather Channel, here's your local forecast, always on the 8s of every hour.
Your extended forecast.
And now, back to the weather classroom.
He was a hard worker. He came to the office early in the morning and stayed late at night and got an apartment 100 yards away from the office and reveled in his work.
The University of Chicago purchased for Fujita a private house next to the U.S. Weather Service building where he set up shop. His work had carried him far, but it would be on the lonely plains of North Dakota in 1957 that a single storm would catapult him to the forefront of tornado research.
Two tornadoes occurred in 1957. One was the Fargo, North Dakota tornado. The other was the equally famous, perhaps more famous, Dallas, Texas tornado. And he had an acquaintance in the Weather Bureau by the name of Walt Hecker. And he and Walt had chatted on the phone that one of them would take one tornado and the other would take the other. And I think there was a coin flip. I can't believe Ted actually flipped a coin because he left very little to chance. But he, for whatever reason, chose the Fargo tornado. So he got started by assembling a massive compilation of footage, films, damage.
And he also did quantitative work. He photogrammetrically analyzed the pictures. That is to say, he determined the width of various cloud features within the storm that produced the tornado. And it's absolutely remarkable that having done this for just one tornadic storm, it turns out that over the years, his terminology has stuck, and we have seen storms that look like the Fargo storm over and over and over and over again.
He had sparked an interest in tornadoes never before seen. By the 1970s, anyone who hadn't heard of Ted Fujita soon would, as he and his students traveled America, documenting eyewitness accounts of storms and developing the famous damage scale that would make Fujita and tornadoes synonymous forever.
This was back in the 70s. We were not as diverse a culture then as we are now, especially out in the heartland of America. I would guess that it was probably the first time many of the Midwestern farmers had ever really spoken personally to a person with very strong Japanese accents. So I'm sure initially they were straining to try to understand what he was saying, but it was amazing that in most cases they would warm up and be eagerly taking him around and showing everything that had happened. And this was here, that was there. The dog flew away, ran back. He came back later that night. Type of stories that would come out of that.
Fujita's scale actually has F0 through F12 in it, and he's very proud of being able to say there was nothing between Mach and Beaufort. Now there is. There's Fujita. He then, with his flair for the dramatic, described the F1s, 2s, 3s, 4s, and 5s. And it turns out that he categorized the F5 as incredible. Nothing could be higher wind speeds, more severe damage than an F5. And a reporter asked him, Dr. Fujita, you have F6 through F12. You have word descriptors for F5 and below. What would be an F6? Ted thought about it for a minute and he says, well, that would be inconceivable. And he still has no word descriptors for 7 and above.
He had done his Fujita scale studies on tornadoes. Now perhaps he was going to move more toward the prediction side, more toward the satellite field. That seemed to be where he was headed, but that all got a bit of a diversion at least when the tornado outbreak hit on that April 3rd day in 1974.
In 1974, a monstrous outbreak of tornadoes occurred of a magnitude that had never been seen before or since. In 17 hours, 148 tornadoes killed 315 people and injured over 5,000 more. Fujita initiated a huge fact-finding mission, conducting aerial surveys over 13 states and Canada.
The enormity of the outbreak began to be apparent to us. He didn't actually have the funding at that time to fly all these aircraft, and the proposal process takes quite a bit of time. On the other hand, he was wise enough to realize that we needed to document this event. There was data out there, damage out there, that the longer we waited would be cleaned up. You could learn about tornadoes. This was the best chance ever to learn about tornadoes. So he actually, until he could get reimbursed, he actually funded the aerial surveys that we did out of his own bank account.
A year later, a single event would suddenly steer Fujita's world in yet another direction. In 1975, Eastern Airlines Flight 66, en route from New Orleans, crashed on approach to New York's JFK International Airport, killing 115 people. The airlines turned immediately to the renowned Fujita for help in detecting the mysterious and deadly winds.
In a microburst, what you have are clouds with some precipitation in it. The precipitation falls out of the cloud where the relative humidity is less than 100%, and it evaporates. And whenever you feel water on your skin and it's dry outside, it gets cold. So the air in the microburst is cold, colder than the surrounding air, and so it starts to fall. Now, any airplane that just happens to be flying through that pattern where it's downdraft and the outflow will first get a headwind gain, so it'll be nosing up because the wind's increasing. If you're landing in an airport, the pilot needs to get the nose of the airplane down, so he pushes down. At the same time he's pushing the nose down, you then fly into the downdraft, which starts pushing the airplane down. So now you have two things pushing the airplane down. And then when you get into the tailwind, what happens is the wind over the wings, which causes lift, decreases substantially, and you essentially stall the airplane and you just start falling with gravity. So you have initially the updraft, the nose down, the pilot's trying to descend, the airplane momentum's going down, and then it stalls and gravity takes over and you kind of essentially fall out of the sky like a rock.
Arguably, somebody would have discovered the microburst at some point. But what I'd like to say is that what price? I mean, how many more accidents, how many more lives would have been lost? Because there were all these accidents all over the world, and it's really Ted that came in and said, look, this is what's causing it. And not only that, he said, this is the solution.
While studying microbursts in Colorado in the summer of 1982, one of the more curious twists in Fujita's remarkable life occurred when the man called Mr. Tornado saw his first.
What was so cute at the end of this episode of Tornadoes was that he turned to me and he said now he could get his license plate changed. It used to be TF0000 for Ted Fujita zeros. No tornadoes did he ever see. And now he said, I can change it. I can be TF0001. And he had this big smile on his face, and it was like a little kid. He was so excited. So it's a great day. It was very memorable.
Don't go away. The Weather Classroom will be right back.
Now, from the Weather Channel, here's your local forecast, always on the 8s of every hour.
Currently in your area, 29 degrees, with rain and some freezing rain. Forecast for your area. Expect fair skies on Saturday and Sunday, and on Monday, expect wintry conditions.
And now, back to the Weather Classroom.
Like his father, Fujita recognized the ever-changing state of the world and never seemed to stand still for long. Mr. Tornado was now a celebrity, recognized around the world for his unique vision and understanding of storms. Fujita had practically become a force of nature himself.
There are very few people that I would run into that didn't hear about Mr. Tornado and didn't appreciate the kind of work he was doing, and maybe didn't fully understand what he was doing, but he was a PR person for meteorology. He brought it to the general public. He was able to explain it. People appreciated meteorology because they knew Fujita.
Ted was, always will be, probably still is now wherever he is, a showman. He has a tremendous rapport with audiences. He can talk to high school students. He can talk to college students. He can mesmerize federal emergency management groups, PTAs, television stations. He loved the publicity.
To study the nature of thunderstorms and their relationship to tornadoes, Dr. Fujita and his associates have built a machine that simulates the thunderstorm-producing twisters, a tornado machine.
It would be very important and desirable to find out which particular one out of 100 thunderstorms will be producing a tornado.
He took advantage of his language, which was neither English nor Japanese. It was Fujita, and he never sought to improve. One of the ironies, I had the opportunity to visit with Ted back in Japan. We went on a 2-week tour with Ted and Susie, and met his brother and his family, and saw where he was born and where he went to school, things of that type. And the Japanese said, Ted's Japanese is no better than you think his English is. So that proved to me that he spoke Fujita.
Well, it is true that Ted, even though he had been in the States for almost 40 years, his English wasn't as good as it could have been. And yeah, he mispronounced a lot of words. But I actually thought that was part of the charm. And I think when he ever spoke in front of an audience, yeah, occasionally there might be a little giggle if he mispronounced anything, but I think they thought it was cute. And I think it just added to his legacy, if you want, that you would not only go and hear a scientifically tremendous presentation, but you would probably laugh through it. And not only because he might mispronounce a few words, which I think was a minor thing, but he also had a tremendous sense of humor. And people really came back saying that this was just enormously enlightening, amusing, just an experience, like going to nowadays an IMAX movie. Well, Fujita was basically IMAX 20 years ago.
He had come into the world with a sense of wonder and curiosity that knew no bounds. His focus and insight was singular, infuriating some, inspiring others.
Ted had tremendous impact on the field. He was controversial, but he forced us to think. He forced us to change our paradigms about the way we think thunderstorms work and operate, or tornadoes, whether it was suction vortices, whether it's downbursts, whether it's microbursts. He challenged us to think in ways that heretofore we would not have thought of.
When he spoke, the entire meteorological community just listened. And it was just an amazing ability. For example, the F scale. He came up with the F scale, he said this is the way it's going to be, and effectively the entire National Weather Service picked up on it. There are very few scientists or meteorologists, or no, I wouldn't even say scientists, they can just say, look, this is the way it's going to be, and then have the whole community just do it.
Fujita, as an observationalist, showed us that one can look at data, stare at it, analyze it, for hours and hours and days and years, and be able to make some sense of the order that's out there.
He would spend a lifetime surrounded by controversy, unlocking the mystery of severe storms. Yet, as fate would have it, his own end would come with little fanfare.
Around a few months before his death, we got word that he was in failing health and that he may not last too much longer.
I was taking most of Ted's phone calls with regard to the press and publicity and NASA and NOAA, because Ted was not talking to them. He would call me and he would say, NASA wants my opinion on, and here it is, but I don't want to talk to him. And I don't want anybody to know my condition.
Talking was difficult at that point, and he was not really seeing many visitors, so that but I got the chance to pass along to him that he had left a legacy to the world, and he should be proud of his accomplishments. And then about a month after that, got word that he had died.
In the early morning of November 19th, 1998, at the age of 78, Tetsuya Fujita died quietly in his sleep. The storm had passed.
It was a loss for the world because of his ingenuity, for his ability to pull in pieces together and form conceptual models. He's the kind of person you would have liked to have lived forever.
He followed through on his own desire, his own philosophy. He was not content with just results. He wanted the results to have meaning. He'd like to work on those projects that had an impact on our life.
He said, look, so I'm wrong 30% of the time. He said, in baseball, that's a hell of a batting average. And he said, and in the end, even the times that 30% or so that I'm wrong, I think I've helped the field. I've got people to think of things critically, and in the end, we'll all be better for it.
Ted Fujita was many things. He was a man. He was a myth. He was a legend. He was a friend.
Ted was an artist in the true sense of the word.
Do you need up to $500 fast? Now you can get the cash you need without driving to a loan store.